day and welcome once again to our class on real analysis, particularly on the topic sequence convergence. In today's class, we'll be looking at how to prove again that certain sequences are convergent. A certain sequence converges to a certain real number. We have done 2 classes on this, and this will be the third one. I take the first question. It says, prove that the limit as n tends to infinity of the sequence 3n plus 2 over n plus 1 is equal to 3. That's what they want us to prove. That the limit as n tends to infinity of the sequence 3n plus 2 over n plus 1 is equal to 3. That implies that we should show that the sequence three n plus 2 over n plus 1 converges to 3. In order to do that, we need first to remind ourselves of our definition for convergence sequence or for sequence convergence. Recall the definition of sequence convergence. Recall the definition of sequence convergence. If you cannot remember this, you are free to look at previous video where I gave the definition for sequence convergence or limit of a sequence. The definition says a sequence an converges to a element of the set of real number if for every epsilon greater than 0 there exists a k which belongs to the set of natural numbers such that what? The magnitude of an minus a is less than epsilon for all n greater than or equals to k. So the first thing we need to do is to identify the k value that works. Identify the k value. In order to identify the k value, we begin from the magnitude of a minus a substitute n minus a is less than epsilon. And that gives me what? Absolute value of what is our sequence an. That's 3n plus 2 over n plus 1 minus where it converges to. That's the real number it converges to, which is 3 to be less than epsilon. And this gives me what? This gives us the absolute value of 3n plus 2 minus 3 into n plus 1 all over n plus 1 to be less than epsilon. And so this gives us 3n plus 2 minus 3n minus 3 over n plus 1, and that is less than epsilon. This gives us the absolute value of minus 1 over n plus 1 to be less than epsilon. But our n is greater than or equals to k, where k element of natural number. And since k element of natural number, it implies that k is greater than 0. And if k is greater than 0, then our n is greater than 0. And if n is greater than 0, then absolutely our n plus 1 will also be greater than 0. And so minus 1 over n plus 1, we can take away the absolute value now, and we have 1 over n plus 1. But 1 over n plus 1 is less than what? Is less than 1 over n. 1 over n plus 1 is less than 1 over n. And this is also what? Less than epsilon. Therefore, our 1 is less than n times epsilon, and then 1 over epsilon is less than n. And if that is the case, remember, it means that n is greater than 1 over epsilon. But n is greater than or equals to k. But n is greater than or equals to k. Therefore, our k is greater than 1 over epsilon. Having gotten k, remember I said we should identify the k value. Since we have been able to identify k value now, we can now move ahead to prove the sequence. What do we want to prove? We want to prove the sequence. Permit me to rub it off from here. To prove, we begin by saying let epsilon be greater than 0, and let our k elements of the set of natural numbers be such that k is greater than 1 over epsilon for all n greater than or equal to k. If that is the case, we want to show that the absolute value of a subscript n minus a will be less than epsilon. We want to show that the absolute value of a subscript n minus a will be what? Less than epsilon. This is less than epsilon. So we begin from an minus a. And what's our an? Remember, that's our sequence 3n plus 2 over n plus 1 minus 3. And that gives me what? 3n plus 2 minus 3n minus 3 over n plus 1. And that gives us what? Minus 1 over n plus 1. And by the time the absolute value takes effect on that one, it becomes what? 1 over n plus 1. But 1 over n plus 1 is less than 1 over n. And our n is greater than 1 over epsilon. N is greater than 1 over epsilon. And what? N is greater than or equals to k. Therefore, k is also greater than 1 over epsilon, as we have seen here before. K is greater than 1 over epsilon. Therefore, this is less than 1 over 1 over epsilon. And that gives us what? That is less than epsilon. Therefore, the magnitude or the absolute value of 3n plus 2 over n plus 1 minus 3 is less than epsilon. And if that is true, it means therefore that the sequence (3n plus 2 over n plus 1) converges to 3. And so this limit as n tends to infinity of 3n plus 2 over n plus 1 is equal to 3. And that is the proof. We will take another example. We will take another example on sequence convergence. We'll take another example on sequence convergence. Or better yet, based on these just concluded examples, you can try your hands on the following. You can try your hands on the following. Try this. Using the definition of limit of a sequence, establish the following limits. Try your hands on it and leave your answer in the comment section. N over n squared plus 1 is equal to 0. Limit as n tends to infinity of 2n over n plus 1 is equal to 2. Limit as n tends to infinity of 3n plus 1 over 2n plus 5 is equal to 3 over 2. Limit as n tends to infinity of n squared minus 1 over 2n squared plus 3 is equal to 1 over 2. Limit as n tends to infinity of 3n plus 1 over n plus 2 is equal to 3. You can also show the following. Show that the limit as n tends to infinity of 1 over the square root of n plus 7 equals to 0. Limit as n tends to infinity of 2n over n plus 2 equals to 2. Limit as n tends to infinity of root n over n plus 1 equals to 0. And lastly, limit as n tends to infinity of minus 1 raised to power n times n over n squared plus 1 equals to 0. You can try your hands on the above and let's know if you are able to solve it. If you have benefited anything from the video so far, give it a thumbs up, share, and like. Thank you. God bless you. I see you in the next video.